I want to address some basic notions that every UI developer should be aware of and be able to explain them. The notions I am talking about are the following: DPI, dots per inch, PPI, pixels per inch, and what's the difference between them, pixel, raster graphics and vector graphics, independent pixel, aspect ratio, and clear type rendering. First of all, it's better, even just for self-education, to understand what's the difference between dots and pixels. Dots or pixels per inch is a measurement of density, the number of individual dots or pixels in a line of 1 inch in width. Dots are relevant only for printing, because monitors do not have dots, they have pixels. A pixel is a physical point in a raster image, and a raster image is a grid of pixels. Generally speaking, the more pixels an image consists of, the better its quality, the better an image resembles the original. As opposed to raster graphics, vector graphics is a mathematical representation of an image. A vector image consists of mathematical shapes like lines, polylines, polygons, circles, ellipses, and so on. The thing is that vector image formats are specifically suited for this kind of representation. All those shapes are described in vector image files, and graphics viewers and editors should know how to read those descriptions and correctly render the images. As to formats, SVG seemingly is the most popular 2D format for vector graphics. Both raster and vector graphics have their own advantages and disadvantages. Vector graphics can be scaled up without any loss in quality, because any mathematical shape can be freely and infinitely stretched. Unfortunately, it's much harder to create complex graphics in a vector format. Another peculiarity is that small vector images can look pretty bad. When such small vector images representing fonts are rasterized, a rasterization process uses special hints in order to make the final image smoother. In short, raster graphics deal more practically than vector graphics with photographs and photorealistic images, while vector graphics often serve better for typesetting or for graphic design. This information is valuable in order to understand the resolution independence of WPF. How exactly WPF supports it? WPF uses logical units in order to properly scale up or down graphics. One logical unit is defined as 1/96th of an inch. What influences on the actual size of final image rendered by WPF? Well, two things: screen DPI and system DPI settings. Let's consider the following case. You have a 21-inch monitor of 9020 by 1080 pixels, so-called 1080p resolution. Then, screen DPI is equal to square root of 1920 squared over 1080 squared divided by 21, what equals 105 dpi. Let's pretend your system DPI setting is set to 96 dpi. Thus, physical unit size of a WPF unit will be equal to 1 pixel, but the real pixel density is 105 dpi, so the real final size of a button declared in XAML as 96 by 96 will be a little bit smaller than actual 1 inch. Aspect ratio is the proportional relationship between its width and its height. The golden format nowadays is 16:9. By the way, the resolution 1920 by 1080 pixels is actually a 16:9 in proportions. The last notion I want to address is a WPF font rendering system. By default, WPF uses clear type in order to render any texts. As Wikipedia says, when the elements of a type character are smaller than a full pixel, clear type lights only the appropriate subpixels of each full pixel in order to more closely follow the outlines of that character. Text rendered with clear type looks smoother than text rendered without it, provided that the pixel layout of the display screen exactly matches what clear type expects. So, before version 4 of WPF, rendering of small fonts in WPF was flawed. Small fonts were blurred if they were rendered by WPF. The good news is that with WPF 4 this was totally fixed. It's a rare case when you should use special rendering modes, so I'll just mention about WPF capabilities regarding this problem. WPF provides two attached properties. The first one is TextOptions.text formatting mode, which can be set to ideal or display. As a rule of thumb, you should use ideal mode if the font size is greater than 14 points. If the font size is equal or less than 14 points, then actually on most modern displays for most people, font has been rendered by WPF should look acceptable. The second one is TextOptions.text rendering mode, attached property, which can be used in order to more granularly manage the font rendering process. It manages the anti-aliasing mode used by WPF when rendering text. It can be set to one of the following values. Auto uses clear type. Aliased, no anti-aliasing will be used to draw text. Grayscale anti-aliasing will be used to draw text. Clear type anti-aliasing will be used to draw text. So the auto value means clear type mode. Fine, let's dive deeper and look at what XAML is in essence.